Through the development of special low-pressure carbon dioxide storage equipment, Tomco Equipment Company presents Carbon Dioxide in Action. In this film, we will present general information regarding the characteristics of carbon dioxide stored in a CO2 storage tank. Just what is carbon dioxide? Carbon dioxide is a chemical compound formed by combining one atom of carbon with two atoms of oxygen and is expressed by the chemical symbol CO2. At atmospheric conditions, the natural state of carbon dioxide is gaseous. Carbon dioxide is a non-flammable, colorless, odorless, non-toxic, slightly acid gas, which is approximately 1 1/2 times heavier than air. Carbon dioxide will not burn or support combustion and will not sustain life. When confined within a suitable pressure vessel, carbon dioxide can exist in any of three states of matter: solid, liquid, or gas, depending on conditions of temperature and pressure. The point at which all three states may exist is minus 69.9 degrees Fahrenheit and 60.4 psig. This condition is referred to as the triple point. Solid carbon dioxide, or dry ice, is at a temperature of minus 109.4 degrees Fahrenheit and atmospheric pressure. Solid carbon dioxide sublimes or transforms directly from a solid to a gas at lower pressure than the triple point pressure without the formation of liquid. Now, through the use of our special equipment, we will actually take you inside the storage unit and show you the carbon dioxide in all of the three states of matter. You are now looking at liquid carbon dioxide with overlying vapor inside a pressure vessel as it exists at normal storage conditions of approximately 300 psig and a temperature of approximately plus 2 degrees Fahrenheit. The boiling effect observed in the liquid is occurring due to normal heat entry through the insulation of the vessel. The ambient temperature at the time of this test was 70 degrees Fahrenheit. As ambient temperature rises, the boiling effect increases due to the greater temperature differential between the outside and the product. The boiling is always present as long as the ambient temperature is above the liquid CO2 temperature. Normal heat leak and other circumstances add heat to liquid carbon dioxide being stored at approximately 0 degrees Fahrenheit, and mechanical refrigeration is commonly used to maintain this temperature. Condensation of CO2 vapors occurs when mechanical refrigeration passes Freon through coils mounted in the vapor space of the vessel. The copper tubes visible on the screen are a section of this coil. When the refrigeration is in operation, the Freon temperature is maintained 15 to 20 degrees Fahrenheit colder than the CO2 vapor temperature. Storage tanks are normally set to maintain a pressure of 285 to 300 pounds per square inch gauge. CO2 vapors are condensed and drop off the coil as liquid droplets when they come in contact with the colder coil temperature, thus lowering the tank pressure. You will notice the droplets of liquid CO2 falling into the liquid bath as this condensation process is occurring. Shown next, you will notice a fog appearing in the vapor space of the test vessel. This occurs when a high rate of vapor is being withdrawn from the tank, either by product usage or by equalizing the vessel with a trailer having a much lower pressure. The fog which appears is saturated CO2 vapor. If the vessel is to be used as a vapor supply, providing other than very small quantities, a vaporizer is required. For every pound of CO2 vapor that is withdrawn from the storage unit, a portion of the liquid evaporates to fill the void. When any liquid evaporates, a cooling effect takes place. With carbon dioxide at 0 degrees Fahrenheit, the result is, with each pound of vapor withdrawn from the storage unit, approximately 120 BTUs are thus removed. The heat is removed from the contained liquid, with resulting decrease in temperature and pressure. It would be possible to lower the temperature of the contained liquid below -20 degrees Fahrenheit, which is the maximum low temperature for which most pressure vessels are designed. Indeed, if enough vapor is removed, the pressure could drop below the triple point, forming dry ice inside the pressure vessel. The size vaporizer required depends on the maximum hourly use rate of carbon dioxide vapor. You will notice a violent reaction on the bath surface being caused by a vaporizer heating element in the bottom of the test vessel. The next scene that you will observe is the lowering of the storage pressure from the normal operating pressure down to the triple point. As the pressure is dropped, you will see the formation of solid CO2 when the pressure reaches the triple point. At this point, the CO2 exists in all three states of matter, that is, liquid, vapor, and solid. Once the pressure is again raised above the triple point, you will observe the solid changing back to the liquid state. The next step will be to drop the pressure through the triple point until we have reached atmospheric pressure. As we continue to withdraw vapor from the tank, more liquid is converted to solid. The volcano effect observed is caused by entrained liquid escaping through the surface. You will notice a mound of solid being formed by the liquid coming up through the surface. This condition continues until all of the liquid turns into the solid state. During this time, there would be no change in temperature and pressure. When all of the liquid has changed to solid, the pressure and temperature will start to fall sharply. This further drop in temperature causes the saturated vapor existing above the solid also to convert to fine snow crystals. And finally, when atmospheric pressure is reached, we have a carbon dioxide snow with vapor above it in the tank. Tomco Systems, the industry leader in carbon dioxide storage equipment.